My name is Travis Lee, and I did my fourth project on blood doping. Blood doping is the process of boosting the number of red blood cells present in an athlete's bloodstream. Since these blood cells carry oxygen from the lungs to the muscles, having a higher concentration of them in the blood will increase the athlete's aerobic capacity and endurance. Blood doping was created in the late 1960s, but it wasn't until 1986 that it became illegal for athletes to do. In the period where there were no rules prohibiting it, blood doping was commonly used by middle and long-distance runners. The most common sports that have athletes blood doping are long-distance cycling, running, and swimming. Since each of these sports are highly dependent on athletes having a large aerobic capacity, blood doping gives them an undeniable edge. There are four types of blood doping used in sports: autologous transfusions, homologous transfusions, EPO injections, and synthetic oxygen carriers. Each kind has the goal of increasing the oxygen in the bloodstream being carried to the muscles by different strategies. All types of blood doping have risks and special tests associated with them. The risks involved in all kinds of blood doping are blood clots, heart attacks, and stroke. Since there are more red blood cells in an athlete's bloodstream while blood doping, the blood becomes thicker, which can cause the veins to form clots. In addition to clots, the thickened blood also causes the heart to work harder than normal to pump the blood throughout the body. This can lead to heart attacks and strokes. The first kind of blood doping is autologous blood transfusion. In this transfusion, the athlete's own blood is drawn and then stored in a refrigerator or freezer to be reinfused before competing. When the athlete's blood is taken, their body replenishes the red blood cells that are missing over time. Once they have fully replenished them, they reinfuse the previously drawn blood, therefore increasing the amount of red blood cells in the bloodstream. The next kind of blood doping is homologous blood transfusion. In this transfusion, athletes use the blood from another person with the same blood type. Since they already have their own red blood cells, the addition of more from another person increases the oxygen flowing to their muscles. There are a number of risks involved with blood transfusions. As a result of tainted blood, a number of infectious diseases such as HIV, hepatitis B, and hepatitis C can be contracted. Also, athletes that repeat blood transfusions periodically can cause a dangerous buildup of iron in the body. Improperly stored blood and improperly administered transfusions can cause acute lung injury and bacterial infection. Since all types of blood doping are illegal in sports, an important factor are tests that can identify whether an athlete has been blood doping. First, we look at the possible testing for autologous transfusions. There is not yet a direct test that is conclusive in identifying autologous transfusions. There is, however, an indirect way to test for it by using what is called the athlete biological passport. The athlete biological passport involves comparing an athlete's blood profile at testing time to blood samples collected at previous times. Significant differences between the two indicate possible blood doping. There are still issues with this test and room for it to be improved. Some problems with the ABT are that microdosage can't be detected, and suspicious profiles in athletes can often be attributed to exposure to altitude, heat stress, or illness. Unlike autologous transfusions, there is a test for homologous transfusions. This test was first implemented at the 2004 Olympics in Athens. It identifies foreign red blood cells that did not originate from the athlete, so they know that there must have been a homologous transfusion. The third type of blood doping is erythropoietin, or EPO injection. EPO is a hormone that occurs naturally in the body by being released from the kidney to stimulate red blood cell production. By injecting more of it, the body creates even more red blood cells, therefore increasing the athlete's aerobic capacity. Because EPO injections thicken the blood like the other kinds of blood doping, they can lead to heart disease, high blood pressure, and even autoimmune diseases. There are also a few ways to test for EPO injections. Both blood and urine tests can identify the presence of synthetic EPO. Although these tests are conclusive, EPO remains in the body for a very short time, but its effects last much longer. This means that the window for testing is quite brief, making it hard for athletes to be caught. The fourth and final type of blood doping is the use of synthetic oxygen carriers. These are chemicals that have the ability to carry oxygen. The two main types of synthetic oxygen carriers are hemoglobin-based oxygen carriers and perfluorocarbons. Like all types of blood doping, synthetic oxygen carriers increase the amount of oxygen in the bloodstream, but rather than boosting the number of red blood cells to oxygenate the muscles, the carriers act as a substitute for them. Perfluorocarbons are able to enter the body's tiny capillaries, providing very efficient local oxygen delivery to greater areas of the body, while the makeup of the drug also allows it to deliver oxygen to peripheral tissues. HBOCs are also smaller than red blood cells, so they are able to fit into smaller places and deliver oxygen more efficiently. Since the synthetic carriers molecules are so much smaller than the red blood cells, they are able to fit between cells and bond to nitric oxide, which can cause the athlete's blood pressure to rise to a dangerously high level. They can also cause strokes and heart attacks. There are methods of testing for both hemoglobin-based oxygen carriers and perfluorocarbons. HbOCs can be detected by routine lab tests that identify free hemoglobin. PFCs are not metabolized by the body and exhaled by the lungs, so they can be measured with chromatography. Finally, one of the most famous cases of illegal blood doping was with the Tour de France cyclist Lance Armstrong. In addition to corticosteroids, anabolic steroids, testosterone, human growth hormone, and diuretics, he was also guilty of Epo injections and blood transfusions. Once found guilty, he was stripped of his Olympic bronze medal and his 7 consecutive Tour de France medals. Overall, blood doping is extremely useful in allowing the athlete to drastically increase their aerobic capacity and endurance, but there are many dangerous risks that come with this. They are also all illegal in most or all sports, which makes it a huge risk for athletes to use blood doping for the advantage it gives them. Any questions?